So the FTC, I'm going to call it fundamental theorem of calculus. If a function, hit focus, is a little blurry there. If a function f is continuous, on the closed interval we'll just say from A to B, and capital F is the antiderivative. We haven't started 5-4, right? Can't remember.
No, I don't think we have.
Okay. Okay, Tyler. On AB, then the integral from A to B of lowercase f of x will equal capital F of B minus capital F of A. All right, so basically you find the antiderivative and then you evaluate the function at those values. Okay. So let's do example 1. So for a lot of you, this should be review. Evaluate the definite integral. So it's a definite now because there's bounds from 0 to 4 of 3t minus 1 squared dt. All right, so first thing you need to do, I would say, is multiply that guy out. So if you multiply 3t minus 1 squared, you're going to get 9t squared minus 6t plus 1 dt. So just integrate each piece separately and then worry about the bounds. Okay. So remember, you can use the rule that says you can separate it as 9t squared dt plus integral from 0 to 4 of negative 6t plus a 1 dt, which is just dt. Right? Okay, so just do a power rule. So that'll be 9t 2 plus 1, right? You remember? Over 2 plus 1 plus negative. Oh, we can just go ahead and make it minus, right? It's already negative. So minus 6t 1 plus 1 over 1 plus 1. plus t from 0 to 4. So once you've done the integration, which we just did, we just need to evaluate from 0 to 4. But let's go ahead and simplify first before we do anything else. So that'll be 9t cubed over 3 minus 6t squared over 2 plus t squared over 2 from 0 to 4. Guys, see, you're still with me right on these steps so far?
Yes.
Okay. So at this point, yeah, we can divide out the 9 by 3, 6 by 2. But let's go ahead and plug in the numbers. So this will become just 3 at 4 cubed minus 3 at 4 squared plus, what's up?
Yeah, that.
Oh, okay. Plus 4 squared over 2. Okay. Yeah, there you go. Minus, then when you put the minus on this part, so I'm doing this part now, right? B minus A. So B was first, minus the A. So I just did the A, so all this right here is my F of B, sorry. Minus, now plug in that 0 into everything. So that'll just be 0 squared or cubed, right? Minus 3 times 0 squared plus 0 squared over 2. So all this right here is F of A. Yeah. That makes sense?
Mm-hmm.
All right, so this is 0, so who cares? So all we have to deal with is this. So 4 cubed, that's what? 4 times 4, 16 times 4, 64. 64 times 3, what's that gonna be?
$64 times 3.
192.
192. 4 squared is 16 times 3. That's negative what? 48, is that right?
48.
4 squared, 16 divided by 2. So finally, we get 148. Yeah. So any questions on any of the steps? So from the beginning, right? Beginning starts right here. We separate the integral just to be clear. Then we found the antiderivative or integrated each piece separately. So this became that, this is this one is t. Then I plugged in the 4. Then I subtracted and plugged in the 0. Right, 4 and the 0. Then after that, we're just adding numbers, right? You guys cool on number 1?
Yes. Can you move the book down a little bit?
Huh?
Over there.
Yeah, no worries.
You were saying this should all be review?
Kinda, yeah. I mean, at the end of Cal 1, they go over antiderivatives, fundamental theorem, and a little bit of substitution.
Yeah, I took it in the spring and we barely touched on antiderivatives. We weren't even tested on it.
Oh, I see. You
So
take it at St. Philip's or no?
No, that was at I think Northwest Vista.
That makes sense.
So maybe I figured it would all kind of be, uniform across the board, but I guess
Oh,
not.
I mean, it's supposed to be, but from what I hear, Vista kind of tends to cut a few corners on math.
Gotcha.
So some of my
That's all good.
coworkers hate them for it, but won't get into that.
Yeah, I'm just doing a little catch up, but it's all good.
But yeah, well, I mean, we're going over it now, so it's okay. All right. Excuse me. Example 2. So we did a few basic integrals last time, right? So now what we're going to do is use the integrals to and apply them to find area underneath some graphs. So that step we just did would be like the final step as part of this problem. So find the area of the region bounded by the graphs of the equations y equals to 2x squared plus x plus 2, x equals to 0, x equals to 3, y equals to 0. So these are 1, 2, 3, 4 different graphs that we're going to intersect together and then find that region of intersection, find the area on that area in that spot, I guess. Okay, so it really helps to graph this. So let me graph it on an online grapher for you to make it a little easier. So the main one is y equals to 2x squared, right? Yeah, there you go. Oops. X equals 0. X equals 3. Y equals 0. Okay. So notice the section that we kind of closed off, right? So the parabola is closing up the top part. The blue line x equals 3, and this is blue, right? Is shutting it down, closing it off on the right. Y equals 0 is closing off the bottom. X equals 0 is cutting it off right there. So this little section looks like a weird triangle thing is the area they want to know. So they're asking us find the area in here. Okay. And okay, I'll try to sketch it for you. This so it's in the notes too. So you got some parabola doing this nonsense. You got the line right here, x equal to 3, closing it off. So we want to know the area in here. So what you do is find the integral. So what I want you to do is picture little rectangles here. Okay. So if the rectangles are facing up and down, which we'll later talk about more in depth, that's going to be your delta x. So we're integrating from 0 all the way till 3. So the bounds are chosen by looking at the graph. So it's going from here to here. The top function is the parabola minus the bottom function, which is 0, y equals 0. That's the bottom, right? You agree with that? That's what I want you to think about it is when you're integrating with respect to dx, you do the top minus the bottom. So this is the top and the bottom. And we'll do more of these towards the end of the chapter, or I think chapter 7 too. More in depth into this, but top, bottom. It's always going to be this way. The top graph is this. Bottom graph is y equals 0. Does everyone see which one's the top and bottom? All right, then just integrate this. So integral, you can just separate each piece if you want. 2x squared dx plus 0 to 3 of x dx plus 0 to 3 of 2 dx.
Can
This
you
would-
bring your paper, please?
Yeah. So the 0 doesn't do anything in this case, but I want you to think of it this way. So integrate 2x squared, we're going to get 2x 2 plus 1 over 2 plus 1 using the power rule, plus x to the 1 plus 1 over 1 plus 1, plus 2x from 0 to 3. All right, so that'll be 2x cubed over 3 plus x squared over 2 plus 2x squared. Oh, what am I doing? Already. Yeah, that's done already. So that'll be 2 times 3 to the third. Let's plug in the 3. Everywhere you have an x for the f of b. And then subtract the function at 0. So it's going to be 0, right? But I'll go ahead and write it this time. So now just add this up and you're done. That'll be the area underneath this curve, or sorry, the area in that region. 3 cubed, that's what, 27? Which will be what, 27 divided by 3 is 9. Times 2 is 18. Plus 9 halves plus 6. What is that? 24. Yeah. Leave it in fraction form. It's fine. 57/2. Any questions on that? On that problem?
You know how you squared 2x where
Yeah.
you like made a mistake?
Mhm.
I noticed that you did that on the last problem too.
Oh, did it?
I think it's on the T.
Yeah, you're right. So delete that guy. There should only be a T. Should only be a 4. So erase that power on the T and the 2 on the bottom. That shouldn't be there. Also over here should only be a 4. This is still 148. This is a 4. Thanks. Okay. You guys cool on number 2? Or this one, whatever that is. That's pretty much it. After that, it just kind of repeats itself. You graph problems, find the area underneath, and we'll hit that more later. So I say we go to substitution, another integration technique, 5.5. And then we can see if you guys have any homework problems or something. So integration by substitution. So here's the theorem on substitution. So basically the antiderivative for composite functions. So let f actually let g let G be a function whose range is an interval I, let's call it I. And let F be a function that is continuous on I. If G is differentiable on its domain and F is capital F, sorry, is an antiderivative of lowercase f, the function, on I, then the following is true. So here's the formula, basically, all that to say that f of G times G prime dx is equal to capital F of G plus C. So basically this is telling you that if you have a composite function, you need its derivative in the problem in order to do substitution. So you can go jump straight to here. So this works for composites. And let me show you why. So in general, letting U equal to G of X gives du equal to G prime of X dx. Therefore, the integral of f of u du is equal to capital F of u plus C. Okay. So the question in the horn we'll first start with, can you identify the u and the du? And then we'll start applying it, okay? U will always be the inside function, the more complicated part. Du will be the outside part. Okay, so identify u equal to G of X, the inside function. And du would be G prime of X, the derivative dx. So the derivative of u is this guy. So part A, you have the integral of 2 times the square root of 2x minus 3 dx. Can you identify which part is u? Right, so it's always the inside. Right, so the inside is the 2x minus 3. So what you have to do is let u equal the inside piece. What is the derivative of u? What is du? What's the derivative of 2x minus 3?
2x.
1x. No, only x.
2, right?
2, yeah. So because the derivative of the constant is 0, this guy basically removes the x, leaving you with just a 2. So 2, well, we're going to attach the dx, right? So we have here. Okay. So now do the substitution and you get the integral. So let me rewrite it so it's more obvious to you. 2 dx. So notice how there's 2 dx right there, right? So that's equal to du. And the inside is u, so that's u. And this is du. So substitute. So that's what we're trying to do. We're trying to simplify the question by substituting. So you should be able to integrate this guy. But integrating this may not be possible without substituting. Do you see the how the substitution works?
What happens to the 2?
Well, du is equal to 2 dx. So 2 dx is replaced by du.
No, from the original function, like the 2 up front.
Oh, I moved it to this 2 is right there.
All right.
I rearranged it so you can see that this is being replaced by du. You see what I mean? Now you don't have to rearrange it. I just want you to see that 2 dx was in the problem. Therefore, du replaced it. Yeah, let's do another one. Part B doesn't fit on this page. Let's just turn the page. You guys cool? Any questions on number 1?
No.
Example 1b, integral of 2x times x squared plus 1 squared dx. So what do you guys think u is equal to? What is the energy function? U.
X squared plus 1.
Yeah, so let's let u equal the inner part. Most of the time will be the most complicated part or something inside of another function. What is the derivative of the u that we chose?
Two X.
2x dx. There it is. Do we have a 2x dx in the problem?
Here's the front one.
Yes.
Yeah, let's rewrite it, right? Just so it's obvious to everybody. 2x dx is right there. So this will be replaced by du. This will be replaced by u. You see what I mean?
Mm-hmm.
So then do the substitution. So we have u squared du. So once you do the substitution, there should not be any x's or dx's. It has to be u du. Okay. Now let's actually start solving them on example 2. Any questions on example 1A or B?
Um, dx.
I'm good.
Okay. Example 2. So now we're actually going to integrate the whole thing. X times 2x squared plus 3 to the 5th power dx. What is u going to be?
2x squared plus 3.
Yeah. 2x squared plus 3. So now derivative of 2x squared plus 3.
4x.
4x. Now we got to attach that dx. So rewrite the problem just so it makes more sense later. X dx. So this, I don't have a 4. You notice that? This is
Yeah.
du has a 4.
Is that a cubed or
So
a fifth? power?
5th power. 5th. Yeah, my 5s are garbage. So divide by 4. So you can have exactly what they have. So du over 4 is equal to x dx. So this is being replaced by du over 4. This is being replaced by u. Does that part make sense? Okay, that's the whole thing for 5.5. If you get that, then great. You're doing great. Because the rest is the same stuff we did last 2 sections after this. So the only new thing is understanding substitution. You guys okay? Right, so that's replaced. And that's replaced. So now it looks a lot easier, right? The 1/4 is in the way. So remember the properties say you can pull out 1/4 in front of your integration symbol. Now integrate and resubstitute back to what we had. So this will become u to the 5 plus 1 over 5 plus 1 plus c. So that'll be 1/4 times u to the 6 over 6 plus c, which would be u to the 6 over 24, right?
Mhm.
And then at this point, the integration has been done, the algebra is done. Just substitute back to what u, because u is a dummy variable. It's not what we're solving for, right? We're supposed to be using x. So come back to x. And you're done. Any questions on any of the steps, so beginning, middle, or end, or whatever?
So that's the final answer over there?
Yeah, so that's the integration of the original beginning part. So we'll use substitution in order to make the integration possible. Or easier. In this case, we made it easier because you could have done it without integration, but it would not have been easy. Check it out. You could have multiplied this out 5 times. So you'd have like a giant list of terms and then multiply by x and then integrate every single term. And you would end up getting the same thing, except it'd be expanded. You'd probably have like 12 terms or something, but this is better.
Okay,
All right. Let's do another one. Let's see here. You guys cool, number 2? Instructions are just integrate. That's it. Square root of 8 minus x squared. So what should u be?
it's kind of blurry, sir.
Sorry,
Is it gonna be 8 minus x squared?
yeah,
Oh, okay.
8 minus x squared. So now what is du?
It'll be 2x dx
Yeah, but it's minus, right?
minus, yeah.
Okay, we don't have a -2 over here. We have the x and dx, right? So let's get rid of that -2. So du over, to make it minus, I guess, is equal to x dx. So now let's replace, right? So this guy is negative du over 2. This is u. Right? So we'll end up with negative du over 2 over square root of u. So that's it. We did the substitution. That -1/2 looks ugly. So let's go ahead and pull that out in front. We'll deal with that some other time later on. Right? Du over square root u. So now we got to integrate this. We could say that this is the same as, I'm going to skip a step here. Let me know if you don't see it. I'm going to rewrite 1 over square root u to u to the -1/2. You see how we got there? Okay. But let me know if you don't. So at this point, just add the power. So that'll be u to the -1/2 plus 1 over -1/2 plus 1 plus c. So now we have -1/2 u to the 1/2 over 1/2. I think my pens are starting to fade. So that'll cancel, leaving me with negative u to the 1/2 plus c, which will be negative square root of 8 minus x squared plus c. Let me get one. Well, let's see. Yeah, just about. Any steps that don't make sense? That's a half, by the way. Is it okay?
Yes.
Let me know if something's weird, okay? Get a new pen since fading. So the integral of sine of 5x dx. So you can do substitution for the inside part, the 5x, right? You can let u equal 5x. Du will be 5 dx. This will be the integral of sine u. There is no 5 there, so we got to divide it out. So du over 5 is equal to dx. So this must be replaced by this. So then we get, you can just pull out the 1/5 because it's in our way. Sine u du. So what is the antiderivative of sine?
Negative cosine?
Yeah. So that'll be 1/5 times negative cosine of u plus c, which is actually negative 1/5 cosine of 5x plus c. Any questions on any of these steps?
Quick question, that one step from sine u to cosine u, that was an antiderivative, right? Or was that a derivative?
This was from here to here is anti.
Anti, okay.
So let me give you a little formula. So if you have a number on the x, after doing these so many times, I started to see it's always going to be this. As long as k is a number, it'll always be negative cosine of whatever number that is divided by k plus c. You integrate cosine of kx dx, it will always be equal to sine of kx plus over k plus c. K is a real number. The K's look weird today. I'm getting tired. Look weirder than usual. Anyway, yeah, if you want to use this, it comes from the substitution, but it's all good. That's pretty much 5-5. Do you guys have any questions on 5-3 or 5-4 from your homework? Well, I'm gonna stop here and leave some time for homework problems.
Can you move the book a little bit down? Need to. Oh, thank you.
So you guys doing okay on your homework then, or
Yeah,
so far?
so far.
That's good.
Still working on 5-1, but
I see.
I don't see a homework for 5-3.
Yeah,
So
there's
there-
no, no, I got rid of 5, 3,
Okay,
I
alright,
think.
cool.
So you should only have, let me double check. 5-1, 5-2. That getting started with calculus stuff, and 5-4, 5-5. So those are the ones that you should have done as soon as you can, I guess. And or bring
5-1,
questions.
5-2, 5-4.
Yeah, and then we just did 5-5. So bring questions next time on any of those if you like.
Okay.
And 5-3 will not be on the test. I think it's all the Riemann sum stuff. So we're almost done with chapter 5. I need to change the dates on there. I think I put September 6th.
We're going to have a review before the exam.
Yeah, we'll have a review over chapter 5. And then we'll have the exam.
So when is this homework going to be due?
I'm gonna change the due date, but I mean, what I would like to happen is you have it finished before I see you again, but I know that's not always possible.
I'll do my best.
But it'll be open for a while. I'm gonna change it. Move it past September 6th.
Okay, gotcha.
I haven't decided what day yet, but by a couple of weeks after that. I'm thinking the day after the exam, homework will close. I just need to choose an exam date.
Okay, I was going to ask that. Okay.
I'll let you know on Wednesday. I think Wednesday we'll finish 5. So Monday we can review. So next Wednesday would be a good day for a test, I think.
Same 10 questions.
No. I'll see. Oh yeah, check.
All right,
I'll let you know next time.
sure.
Jose, you have a question? 1 second. Number 11. Okay. Alrighty. So number 11. .1, number 11. Right, see you there, Krishal. No worries. All right, so integrate 3x minus 7 over x dx. So we can separate them. There's what the rule said. We can also pull out the constants. Integral of this guy would be x 1 plus 1 over 1 plus 1, and that 3 is right there. Minus integral of 1 over x is the logarithm. This is the ln rule, so it'll be minus 7 ln x plus c. So the answer will be 3x squared over 2 minus 7 ln x plus c. Is there any steps you didn't catch, Jose? Does that make sense?
Yeah, it makes sense.
Just remember the rule for log, right? And that should be good. So this will always be this.
Oh, okay.
It's one of the ones on the formula sheets. All right, Tyler, I'll see you later. Yeah, I'll type that. Okay, any other questions?
That'll be it. Thanks.
If you don't have any, you can head out, and if you want to stay for a bit, let me know. I'll wait around for a little bit.
So are we going back to face-to-face classes?
I don't know. I think right now it looks like maybe on Tuesday, but they'll might change their mind on Friday. I don't know. So as soon as I know, I'll send an email. I hope I know by Monday, the latest, but they should tell me by Friday, but we'll see.
Okay. So are we gonna be using the computers from the school or how we gonna do that?
I think it's gonna be just a normal classroom.
Okay,
We have what, like 10 people? I can't technically